Odds and evens. So, in case you forgot, the difference between odd and even numbers is that the odd numbers are not divisible by 2, while even numbers are. When an integer has more than one digit, always look to the last digit to discern whether the number is odd or even. Let's look at some operations with odds and evens. For multiplication and division, 2 even numbers will always result in an even number. An even and odd number will also result in an even number, while 2 odd numbers will result in an odd number. For addition and subtraction, both 2 even numbers and 2 odd numbers will net an even number, while an even number and an odd number added or subtracted will net an odd number. Exponents are easy. An even number raised to any positive integer will result in an even number. An odd number raised to any positive integer will result in an odd number. Negative exponents will create fractions, but we'll get to that in the exponent lesson. And when listing odd and even numbers, don't forget that 0 is an even integer. Here are a few helpful things to remember regarding odd and even numbers. A number n is even if there is no remainder when the number is divided by 2. In other words, the number is evenly divisible by 2. This can be written as n equals 2z plus 0, or n equals 2z. If the remainder is 1 when a number is divided by 2, then that number is odd. This can be written as n equals 2z plus 1. The product or quotient of an odd number of negative numbers is negative, and the sum of negative numbers is negative. Let's take a look at an example problem. If the sum of 3 consecutive integers is odd, then the first and last integers must be. Okay, to start, let's let the 3 consecutive integers be x, x plus 1, and x plus 2. The sum of these integers is 3x plus 3. The question states that the sum of these 3 integers is odd, so that means that 3x plus 3 is odd. Remember that if the sum of 2 integers is odd, then one of the integers is odd and the other is even. Since 3 in the expression 3x plus 3 is odd, then 3x must be even. Now, if x were odd, then 3x would be odd, because an odd number times an odd number results in an odd number. So that means that x must be even. If x is an even number, then x plus 2 is also even. Thus, the first and last integers must both be even. Let's look at another problem. N is an odd number greater than 5, and a multiple of 5. Column A is the value of the remainder when n is divided by 10, and column B is 5. What is the relationship between the two columns? We can start by finding the possible values of n. The problem tells us that n is larger than 5 and a multiple of 5. So, listing these, we get 10, 15, 20, 25, 30, 35, etc. We know that n is odd, so the possible values for n in this list are 15, 25, 35, 45, etc. Any number in the list when divided by 10 will leave a remainder of 5. Therefore, column A equals 5. Our answer is that the two quantities are equal. Let's try another. The value in column A is the number of positive integers less than 1,000 that are divisible by 3. The value in column B is 300. What is the relationship between these quantities? Let's find out the value of column A. We're told that it is the number of positive integers less than 1,000, which means that we'll be working with numbers ranging from 1 to 999. Now, we need to find the total number of integers in this range that are divisible by 3. Well, every third integer in this set of numbers will be divisible by 3. So to find the total number, we simply divide 999 by 3, and we get 333. 333 is greater than 300, so column A is greater.